Thank you very much, ladies and gentlemen, and welcome to this fantastic panel discussion on innovation and the technology in the potato production sector. On my left is, of course, Professor Martin Steyn from the University of Pretoria, Yechiam Getz from Netafim, Mr. Vikar Shivaprasad from John Deere, and Murray Thompson, Chairperson of Potato South Africa. So to kick it off, let's talk about irrigation and irrigation scheduling. Again, Martin, I'd like to find out from you, a potato producer, we've heard all about irrigation scheduling now, but how does a potato farmer decide which practice will work the best on his farm?
Thank you, Gerrit. Yeah, I think it's almost like deciding which is the best bucket to buy. It has a lot to do with preferences. It has a lot to do with what will work well in your conditions. For instance, I think most soil probes are probably mostly used in potatoes in our country of the different methods. But in some regions you'll find growers say probes don't work so well. For instance, in the Sandveld or in areas where soil is very variable. So I think it's probably not one better than the other, but it's a matter of having a toolbox and a set of tools available and using what suits you best. I think a trend that we see also in the past with especially capacitance probes that got quite popular in the last 10 years or so. I think farmers bought the equipment and had to sort of, with the help of the companies, get along and install and use the probes, and then maybe after a year or two you find the probes being packed in the corner of the shed, not being used anymore. So I think nowadays better support also companies that provide services and advise farmers, help them to install it, help them interpret the readings, help them to make decisions. I think that's helping a lot. But I have a lot of hope for this new trend that I spoke about remote sensing and weather data in combination to sort of boost this atmospheric approach, which I think is I would always recommend that you still use some other backup. You still install a probe or still go and check regularly. You can never depend on one thing on its own. So it will always be a combination, but I think I have high hope for that taking off in the future.
Yeah, and of course, probably the most important, the farmers' feet right there in the field. Now, Yechiam, we were just talking about probes and their application in South Africa. When we hear about that, I almost get the feeling that sometimes they end up in the shed. What is the definite role that you see moisture probes can play at the end of the day?
Well, the professor was mentioning it as well. I think some way of monitoring is crucial. Otherwise, you are just blind in the field. Mm-hmm. So the main thing will be surface work.
Try it again.
I don't know. Can you hear me?
Yeah, now we can hear.
Okay. 1, 1, 2. All okay?
It's on and off.
It's on and off.
I don't know.
Yep.
Try to talk like this. Can you hear me okay now? Okay, I'll speed up. The main thing is really that it's the combination. For example, I was talking to the professor back then. You need to monitor somehow. For example, in North Europe, we have farmers rarely new to drip irrigation. So for them, soil probe is university. So we take them kindergarten. We give them a very simple irrigation scheduling. This week, this is your ETC. This week, you have to irrigate 2, 4 times, depends on your soil type. So this is kindergarten for them, but everybody have to start from kindergarten. Soil probes, on that matter, is for the high users. And I've been touring here the past 2 days, I know South African farmers. I'm a big fan, by the way, of the soil monitoring and probes. I learned a lot from the South African culture, let's say, of soil monitoring. And I think the professor was mentioning maximizing water use efficiency. I met today already with 3 farmers talking to me about the level of their reservoirs going down and down. So combining some knowledge, for example, atmospheric approach, but with the addition of soil probes, this is university, master's degree, professor degree, whatever you want to say, it will take farmers to the next level in terms of water use efficiency. And it's really the combination of the whole things. And of course, soil probes are essentials to go to that university, but nothing replaces the farmers in the field looking at the plants, and the combination of the whole 3, atmospheric or remote sensing approach, but basic knowledge that was developed, adding the soil probes to it with online monitoring and online decision supports, and of course, the green fingers of the farmer is the winning combination for all of this.
Yeah, I'm glad that you touched on the Northern European example, of course, and water usage. South Africa, which is a traditionally very water-scarce country, and I mean, potatoes run on water like the Prado runs on petrol. So what I'd like to find out from you, you were talking about drip irrigation, and when you look at it in a South African context, do you see a viable future for it in a South African context with our larger fields, with more area? How do you see that?
Yeah, it's a good question. As I said, there is no one solution fits all. It will depend upon your yield targets. If it's fresh consumption or industry or starch potatoes, seed potatoes, also we didn't talk about it all. Your varieties that you choose, your soil type, your local climate. Cape Town is not the same as Limpopo, of course. All in all, talking about water scarcity, talking about maximizing yields, and really using this 1 cubic meter in the maximized well to get your yield, I see big potential, especially on those niche when you have the combination, either reduction of yields due to the changing climate or water scarcity from some reason. And by saying water scarcity, we are also talking about, okay, maybe you have the same amount of water, but the salinity is increasing due to all of those factors and changing climate. So, unfortunately, as we see these changes in climate, the same happens now in Europe. I come from a very desert country, much hotter than here and much less water. And unless you start bringing water from desalinized water or reclaimed water, you have to deal with your water. And so I see a lot of potential for those solutions in the right places. Of course, it will remain a pivot culture industry because in many big plots, big farms, this is the nature and the culture of the industry. All in all, there's still a lot of room for adoption of drip irrigation on that matter because of the reason I've mentioned.
Yeah, it's like Martin said, assess your environment and see how it fits into your practice. Now, Martin, I would like to find out from you, if drip irrigation is so efficient, why do we not see more of it around the country?
I think it has a lot to do with practical aspects. I mentioned in my talk also, the work that we did showed that it can be used, it can be very successful, it can be efficient. But in the same breath, I want to say I've seen drip irrigated fields being very over irrigated because of not understanding the technology and managing the technology well. So it is a more complicated system. It must be well designed. You probably need a computer to manage valves and things like that. So it is a more complex system. I think in many of our production regions where we do not have rainfall before preparation, before you plant the next crop, it is impractical to roll out drip to wet the field, to roll it back to prepare the field to plant the crop. Or you have to have a dual system where you have to have sprinklers to wet the field to prepare the soil. So I think it's those practical things that make it difficult to use it on a larger scale. There are, of course, smaller areas of drip. I mean, there are farmers in here that are dripping potatoes, so it's not that it's not working, but I think it has a lot to do with the practical aspects. And as I've mentioned, I mean, it is a fact, it's been proven that overall, if you compare drip to pivot and drip is well managed, it can save water, definitely. Mostly in the part of the growing season when the soil is not completely covered by crop, your evaporation losses will be less. And of course, if your pivot is well managed in the rest of the growing season, there should not be much difference, but especially in a part of the season when the soil is not completely covered. So I see certain niche sort of areas or applications where it can work and where it probably will in future increase, but I cannot see that it will take over pivots in the near future in our country because of those practical reasons.
Yeah, so once again, like with all types of technology, I think it comes down to the farmer assessing the issues on his farm and finding the best solution at the end of the day.
Yes.
Now, I'd like to ask both of you to maybe give us a bit of an idea, let your minds go a little bit, and tell me the ideal smart farm when it comes to irrigation. How do you see that? What does it look like?
Do you go first?
No, you go first.
One thing I've always said, and maybe that's not so directly linked to irrigation, but the whole farming system is we see precision farming applications in almost any crop, any cash crop that we grow, but we don't see it to its fullest extent in potato production. I think one of the big reasons for that is the fact that we cannot yet on a big scale have yield maps like we have for maize or grains, whatever. And I think the big advantage comes when you have precision soil analysis, precision fertilization, and you can overlay those maps with yield maps to sort of optimize the system. And I hope it's something that will be coming soon, because potato is a very expensive crop to grow, and you want to utilize each part of your field optimally to its best potential. I think only when we get to that point we can also start looking at all these new high-tech equipment coming in, like variable rate application irrigation systems, pivots, and so on, where different parts of the fields can be irrigated separately depending on the soils and the potential of different areas and so on. And then, of course, ideally, I would like to see on every farm that some form of irrigation management is used, either being probes or a combination of probes and atmospheric methods or whatever. But I think in general our farmers are doing very well. If you look at the water use efficiency numbers, and we've monitored many fields in different production regions. So it's not only from that survey, but also measurements that we did in all the production regions. Efficiency of our farmers are in general good, but you can, from those graphs that I've shown you, there's clearly in some instances room for improvement, so that we get to that point that we can really say that we utilize our resources optimally.
Yeah, first of all, I agree with everything the professor said. And just adding up to it, of course, there are all of the high-tech solutions that coming in, and the spaceships and the robots and all of those things. But at the end of the day, the ideal smart farm, just relating as an example to where I come from, the water, is just the first step to be a smart farm is really to measure the things. We can start even on simple things like measuring the amount of water per hectare, per plot. Some farmers are doing it, some farmers are a lot. South Africans, again, are in a very high level compared to other countries, trust me. But going back to basic measuring the water, doing leaf and petiole analysis, which is very common once a season, let's say during tuber initiation, and get from the academy or the industry, get the threshold and see, am I in the correct thresholds for my nitrogen, yes or no, should I add? Basic things, soil analysis before the season, analyzing the yield, the caliber, the size. Those things will put you much more advanced in the way to be smart farmers. Of course, if on top of it you put soil probes, which is online monitoring, and control, which is online monitoring, then you have everything at the tip of your phone. This is already, it puts you in a very, very precise, and I'm talking globally now, most of the farmers and the farms are far away from there. So this is the basic idea is going back to basics, measuring, documenting everything year by year, because you learn also from this experience, because no year is the same, even though it's the same field or the same farm. Doing those basic things really will put you in the smart, and then you can advance to the next level, to all of the robots and the spaceships and the high-techs. But just doing the basics at the beginning will put you there.
So it all comes down to monitoring and interpretation at the end of the day. And I think your mechanization and technology manufacturers have got a big role to play in that. And of course, that's why we've got Vicar on our panel as well. So Vicar, what are some of the exciting innovations when we look at potato farming in South Africa that John Deere can bring to the table, especially when we look at things like monitoring and interpretation of this data?
Yeah, so I actually like the answers that they were giving and the direction it was going, because that's exactly what John Deere has to offer. We have GPS technology that we use today. It's not just only for getting you guidance, getting you to drive in a straight line. With SFRTK, you can get up to 2.5 centimeters accuracy from the satellites. But also it will give you as-applied data. So it will allow you to get GPS coordinates of your field, and every application and job step you do across that field, it will document that data for you for you to come back to allow you to do variable rate applications. John Deere does have like rate controllers where you can put on non-conventional spreaders and sprayers, whether it's wet or dry, to make those variable rate to allow you to save on your input costs. But also giving you that documentation to make better decisions on your next job step. And for Prof there as well, we're also looking at in the coming months, we're going to be testing what we call heel dock, where you put that on your harvester with weigh cells on there, and then you can start documenting some of that harvest data that you will be receiving from your fields. So allow you to make better decisions for the coming season as well.
So we know that potato farming is very labor intensive and very time sensitive. Let's talk a bit about automation and smart farming. How do these developments help to relieve this operational pressure on a potato farm?
Yeah, so automation, there's different levels of automation. We have AutoTrack today for farmers on our tractors, where it will allow the tractor to drive hands-free in a straight line for you, which will allow the operator to focus on other stuff, but also getting the job done much quicker, and then less operator fatigue, so less errors that you will have in your field. We also have what we call implement guidance and autopart. So with implement guidance, you put a GPS receiver on your implement, and it will give you that 100% accuracy you need. So with your potato ridges and stuff, it will be accurate. So when you come in for every other job step after that, you're not trampling, you are on that straight line, so you don't have damages of crop. So we don't directly affect the yield productivity, but we have some solutions that can help you within the operation.
Yeah, I think you say that it doesn't directly influence the yield, but I think when you take out some of that human error, I think it does have a bit of an influence on the yield at the end of the day. But now, when we talk about manufacturers and their different technologies, one of the things that we have to talk about is that a connected ecosystem. Now, of course, we know about JD Link and Operations Center. How do these systems help farmers realize and improve their ROI, especially when making these data-driven decisions?
Yeah, so a life of a farmer is a busy life. He's not just in the field. He has to run a business. So with having JD Link on the machines, it allows him to not having to be in the field 24/7 monitoring machines, looking at what job step is done, what application has been done in the field. So JD Link will allow you to connect all your entire fleet, and then also allow you to remotely monitor your equipment, but also monitor every application that you're doing through that field. So he can be anywhere in the world and still have access to see what's going on in his operation, but and also make the next steps or the next decisions that need to happen. So if this tractor is planting this field and he's 20% finished or 80% finished on that field, he can already start planning what's the next field that tractor needs to go to. So, productivity continues throughout the day. But it also gives you that seamless data to and from the machine. And then you can also monitor your equipment, the tractor itself, how efficient it is, what's the productivity of it, whether that operator is standing on the field idling instead of being in the field planting or spraying or whatever needs to be done. So you're actually looking after your entire fleet without being in the farm.
Now, Vicar, I'd like to ask you, with all this technology, at the end of the day, it's still a machine, nuts and bolts. And as we all know on a farm, sometimes accidents do happen. So I took a look at the potato production areas in South Africa, and it's very interesting to me with our potato production, you've got very centralized, and then we've got some very far-flung areas around the country. So how does John Deere make sure that these farmers are properly serviced, especially when it comes to their parts and also their services?
So yeah, we have a vast dealer network that we cover most of South Africa with, but connectivity plays a big key part of that as well. And we actually rolling out a strategy in South Africa with our dealers as well is what we're calling centralized and connected support. So having our machines being able to be connected, our dealers can now monitor those machines working in the field. They can monitor when they're due for service, so they can already have a technician lined up to come service that machine to reduce downtime. But what we're also getting to now is, due to the years of data that we've been gathering over the machines, we can now predict and prevent failures on machines before they actually happen. Dealers will get an alert saying that this machine is about to fail, or there's going to be there's certain error codes in a certain sequence that might cause this machine to fail. Please contact the customer and stop that machine immediately. These are the parts you need to go and service that machine with. And then the technician goes out one time, diagnoses, fixes the problem. So it reduces the downtime of that machine and saves the customer money, because it's not a catastrophic failure anymore. It's just maybe changing an O-ring or replacing the oil, and that machine is up and running again. So centralizing our support system, it also gives dealers, customers access to technicians, because there is the knowledge at the centralized support center where customers can contact and get advice on whatever they need, whether it's the precision ag piece of it or anything technical on the machine. And then they can put them to the most knowledgeable person, but the next person that's available. So he doesn't always have to speak to a person at his nearest dealership. He can be put through to someone within that dealer network that can help him and advise him. So reducing downtime there again. So that connectivity piece just opens up a lot more worlds for that opportunity for a customer to be serviced.
Now, Murray, I'd like to ask you, as a farmer with your feet in the land, there's this perception that South African farmers are conservative by nature, and we tend to, while we take notice of the technology, a lot of farmers tend to say, well, this has worked on my farm for so long, why should I change this? But at the same time, to remain competitive, we need to be cognizant of bringing in technologies that work on our farm. So I think what I'd like to ask is, what does that golden mean? How do we marry these two concepts from a conservative approach, but still bringing in new technologies to help you go further?
Well, thanks very much. Yeah, I think the perception that farmers are very conservative and to a certain extent technophobic is while objectively potentially true, maybe not a fair argument. There's a huge risk involved with bringing in any new systems, technological or otherwise, that we only get, as I mentioned this morning in my introduction chat, you only get one chance a year to make a mistake. So if there's a failure that happens, it can have long-term catastrophic effects for us. And then to bring any new technology, I think there are probably four main things or categories that it needs to fulfill for us. One is it scalable? A lot of the new technology that comes out is really great on a smaller scale and a more European-sized farm. that is a lot more manageable. Potatoes sort of falls into a in-between category where a few hundred hectares is not mega scale like a grain or something like that, but it's also it's not on a micro scale. So is it scalable will be the first hurdle that it needs to get through. The second one, is it affordable? If you look at agriculture in general, compared to other primary industry like mining or that type of thing, our margins are finer, so we don't have an infinite budget to throw at technology. The corporate farming in South Africa is definitely in the minority at the moment still, so it's mostly sole proprietors or small businesses or medium businesses that are running this, so there's not necessarily large budgets for that. The third one I would say would be how reliable is it? And with that, it comes down to, is there technical support should it fail? These are also something that, how do you get the new technology into a region? Because you have to put technical support there for the first person to use it, but that's not economically viable for the supply either. So that's another one. And then I would say the last one is it Africa-proof? And by that I mean we have extreme weather here. We have animals that you'll be surprised how destructive they are on things like moisture probes and that type of thing. We have severe heat and extreme cold on the same farm in the same area. We have limited, I speak on the platteland generally, we have limited skills available. So we have a reasonably lesser skilled labor force than other parts of the world does. So to bring new technology in a semi or unskilled employment environment is also difficult. So new technology has to fulfill all four of those before the first farmer would even think about it. And that's why I think the adaptation is slower than many of the amazing technology providers would like it to be.
Yeah, I think conservative might be a strong word. I think careful.
I think careful is a better word.
Might be a better word for looking at it that way. I want to throw you a curveball and ask you technologies that you've seen over the past year or so. What has caught your eye? What has made you look at it and gone, I wonder if I can use this on my farm. I think there's a place for it.
Just to do a slight sales pitch to my right here, I think the JD Link technology, I mean, it's older technology. I'm not sure how many years old it is, but it's been around for a while. I think this is something that fits all four of those categories for me. It's something that is easily scalable. It's quite easy to do. The user interface is really easy. The support is all there, so everything is in place for that. So I think that would probably be the one that in my business we're looking at in the most short term, let's say.
That's fascinating. Gentlemen, I'd like to thank you very much. Thank you so much for contributing to this panel discussion. I think it was a very interesting talk, and thank you once again. Ladies and gentlemen, thank you so much for joining us. It was a fantastic and lovely having you here.